me really make sure the sound is working, Amjad, since this is a tricky one. Come on.
But sometimes we do like that and sounds.
No, I'm really checking. There we go. See, there's the sound. Amjad, testing. There we go. Definitely working.
Yeah.
All right. Now, first thing to say, here is a very simple trigonometry equation. If I say sine x equals a half, that's a simple equation. If you want the x here, what do you use on your calculator? Sine inverse. So type in sine inverse a half. What's wrong, Abdul? No? What do you get? 30. So go back to this equation here and check if it works. Type in sine 30, and do you get a half?
Yes.
Yes. Yes?
Yep.
Now, I want you to type in sine 150. Half. You see? Yes? So my point is this. The calculator gives you one answer, but in fact there are two. This is like square. Okay? X squared is 9. If x squared is 9, what's x?
3 or minus 3.
3 or minus 3. In a similar way, the calculator only provides you with one answer for sine, cos, and tan equations, but in fact there are two answers. Like in this example, the first answer was 30, and what's the second answer? 150. So the question is, how do you get the second answer from the first answer?
Minus.
Well, for sine, some of us know. It's 180 minus the first answer. This always makes the second answer. Okay? Now, for cosine, does anybody know cosine's rule? No.
360.
360 minus the first answer. And lastly, the tan. Oh, good, Moona, you remember these ones. 180 plus, Amjad, you didn't. You remember these? No, okay. 180 plus the first answer. So I'll say it again. These answers go in pairs. And your calculator gives you what you might call the primary answer or the principal answer. And these here will be the secondary answer. Okay. So with that in mind, we can now look at more complicated equations. So let's have a look at our first example. So I should also point out, you must know this off by heart because it is not in the formula book. Important. Okay. So let's have a look at an example. That's 360. So I give you 360. I give you this equation here. Now, sine by itself has two answers. And I know from looking at this that I'm expecting 4 answers here. And the way you can tell is that the number of answers should be twice the number on the x. So that's 4. And if it was sine 3x, 6 answers. Also, I tell you the x should be between 0 and 360. So how do we solve this? There's a process to solving this. The first thing you need to do is rewrite it so that you have sine equals. So if I take the minus 3 to the right, I get, sorry, that's a 5 by the way, I'm sorry. So I get minus 5 sine 2x plus 5 degrees equals 3. And then what will I do next, do you think? Divide by minus 5. So I get sine 2x plus 5 degrees equals minus 3 over 5. So that's the first step. There's 4 steps here. That's the first step. Well, it's near the end of the first step. What we do now is we put the sine inverse in on our calculator. So we have 2x plus 5 degrees equals. So can somebody please do sine inverse minus 3 over 5 and give it to me to 1 decimal place? What do you get? Minus 36 point. But how many answers do you get? There should be 2 answers here. Remember, I said the calculator provides only 1. So how do you get the second answer for sine? 180 minus 36.9. So that is 180 plus 36.9. What is it? 2? Sorry, way off. 0.9.
180 plus the inverse of sine or...
Wait. No. Don't guess. I'll tell you what's happening next. And it's not that, sorry.
No, I mean, how did you get minus 36?
Oh, sine inverse. Yeah, minus 3 over 5. Minus 3 over 5.
Okay.
Yeah. Now,
180 plus first answer.
minus, however.
Because it's minus, so it's plus.
Yeah, right. Now, we have 2 answers. But how many answers at the beginning did I say we were expecting? 4. So, the next step is you generate the extra answers that you are missing. And the way to generate the extra answers is actually not so difficult. You generate the missing answers by adding 360 to the answers you do have. Now the reason for this is because if you have an angle of 10 degrees and you swing around 360, you're back at the start. So this means the angle 370 is actually the same as 10. So it is perfectly fine to add 360 to an angle and the equation still holds true. So, hang on, let me write down the 2 that we have. What did you say the next one is? 3, 2, 3.1, and then the last one here? 5, 7. Okay. 1, 2, 3, 4. What's that, Amjad?
Where do you come from the third and the fourth?
Where did I get the third and the fourth answer from? Adding 360 to what? The first 2 answers. Yeah? Oh my... No, hang on, we're getting confused here. Andy? No. Shh. There's confusion happening here. Let me clarify something for you. Okay? Firstly, are these right here, or did somebody add them in wrong in the calculator? That's not what you're telling me, is it? No, okay. So wait. Listen very carefully. Your calculator provides you with... No, I want everybody looking up. Okay? Your calculator provides you with 1 answer. That is this answer here. But how many answers should there be? In total 4, but forget about the equation. Just normally there should be 2. A first primary answer and a secondary answer. So this one you get from your calculator. This one here you get from your calculator as well, except you have to type in 180 minus the first answer. So in a way, the first 2 come from your calculator. Answer 3 and 4 are always sine, cos, tan, it does not matter, 360 added onto the first 2 answers. If we needed 2 more answers, we would add 360 onto the 3rd and the 4th answer to make a 5th and a 6th answer. And so on to make as many answers as you need. So look, in some essence, this is the true original answer. This answer comes from this, by doing what? 180 minus the first one. Answer 3 and 4 come from 1 and 2. Answers 5 and 6 come from 3 and 4, and so on, and so on.
How
Now,
do I know how many answers do I need?
and again, can somebody tell him how many answers do you know to have? It should be twice this number. Yep. I am speaking slowly, loudly and clearly enough, yeah? Yes? Right. Question now, Andy. Wait, hang on, Andy.
Why there's negatives?
The negative will be taken care of later. I'm not finished yet. Don't worry about the negative yet, okay? That will have its own step. That will be step 4. Alright? So, do not worry yet. Now, that is the end of step 2, making the extra answers. Step 3 is to simplify these answers because, look carefully, these answers do not represent x. What do they represent? 2x plus 5. So now, to get the x, what you do is minus 5 and then divide 2. So to speed things along, no, you know what? I'll split it up into you. You simplify the first one. Minus 5, get the answer, and then divide 2. No, you're not Amjad. You wish you were Amjad. You're not Amjad. Right? You do the second one, please. Third one and fourth one. And don't worry, we'll have backup as well. You double check the first one. You can double check the second one. Can you do the third one? I trust you. Yes, third one. And Eamon, double check the fourth one. Wait, hold on. Right. Now, X here. So, Amjad, first answer.
Minus 20.95.
Are you double checking his?
Yes.
And it's not that.
No.
Are you confident? Because you're accusing Amjad of lying to his teacher, yes? What?
What did you do?
Minus 23? 0.45.
Look what I did.
Now, you said it's minus 20.95. Let's see. I'm sorry to tell you this. It's looking like Amjad was right.
Minus 36.9. Yeah. Minus 5.
MB, I think you owe Amjad an apology. Yeah, it's minus 20.95 degrees. Okay, now, thank you, Amjad. The second answer, what's that?
105, go to 95.
Okay, and who was double checking the second answer? Yes, that right? Yeah. Okay, the third answer?
159.05.
Yep. 0.05. And then Fatima, have you got the fourth answer?
Yeah, I think it's wrong. I don't know. 285.9.
Okay. Who was checking that one?
Yeah.
Yep. Okay, good. So that's the end of the third step where we find the x. And then the final step, Andy, the fourth step, is we have to fix any angles that do not meet the requirement. What is the requirement? I need x to be between 0 and 360. So if we look here, this one is fine, this one is fine, this one is fine, but this one here is not fine. Now listen carefully. That does not mean I reject it. I keep it, but I have to fix it. Now, how do I fix it? The way to fix an angle that is negative and you want it to be positive is just add 360. So please add 360 to that, and what do you get? 339.0. So I fixed this answer. I wrote it at the back because I want to write them in order. So the smallest answer is 105.95. What's next? 159.05. Next? 285.95. And then finally is that answer, which was me fixing the first answer here. It was, the way I got this was taking this broken answer and adding 360 to it. This is a point here. This is right, is it? Looks okay. Yeah.
Is it this one I eat doesn't eat everybody?
Yep, don't ruin the surprise now. So, let me label the steps for you. Don't worry, I'll scroll back down. Look. So the first step is to get it to this situation where you can calculate the inverse. I'll call this step the I step, getting it to an inverse. Okay? The second thing to do is make those extra answers. I'll call that the E step for extra answers. The next thing to do is to simplify the angle into an x. So I'll call that the S step. And the last step is to fix any broken angles. I'll call that the F step. So you have steps I, E, S, F. Amjad, go for it. Go on.
I eat sausage every Friday.
No, oh no! So, I eat sausages on Friday. Yeah. Because, listen, the order is important. If you don't do it in this order, you will get the wrong answer. So the order in which you solve this is extremely important. You must first get the inverse step. Then you must make the extra angles. Then you must simplify, and then you must fix the angles. If you did something like inverse, simplify, fix, and then make the extra angles at the end, that would be wrong. Or even if you make the extra angles after simplifying, again that would be wrong. So the order is extremely important, and it must be in this order, and we thought of a way to remember it, and it's I eat sausages on Friday. But unfortunately, Amjad said I eat sausages every Friday, which would be I-E-S-E-F, which is not going to work at all. Okay, so these questions here, the nice thing about them is they follow the same process each time. Okay? Now, I'm going to do an example from number 2, which is much more difficult. Or yeah, I tell you what, I'm going to do, well, no, I'll do number 2. I'll do number 2, 2A, okay? So do you need me to scroll up here or not?
Yeah.
To here or further? Further.
Just to know that.
It's question 1A. So that's the start of the answer. Now, while some of you are writing this down, look at 2A. What type of equation does that look like in 2A? It's quadratic. Okay? So, in fact, 2A, I won't fully solve it, but I'll do some of it just to get you started on it. Okay? So if we have a look at 2A, I have to start it now. Sorry if you didn't have a chance to write it down. There quickly if you need to get the answers down at least. So 2A, you need your calculator for this. So you have 49 cos squared minus 3x minus pi over 180. 18. Oh, sorry, thank you, 18. Minus 70 cos minus 3x minus pi over 18 plus 25 equals 0. Now, if you were to look at this, you'll notice that here is cos squared, and here is cos, and here is no cos. So this is of the form 49 something squared minus 70 times something as well, plus 25. Well, these are the same. The only difference is this one's squared. So, of course, this type of equation is a quadratic. A is 49, B is minus 70, and C is 25. Using your calculator, please tell me the two answers you get. Just one answer here? Okay. So you get 5 over 7. So what is equal to 5 over 7? Well, the x, the variable. And what's the variable here? Cos minus 3x minus pi over 18 equals that. Now, does this question look familiar? Yeah, it's exactly like the example I just did here. So, although question 2 looks much more difficult, it's just the same as number 1, except you might have to do twice the amount of work, because what could have happened here is I could have gotten 2 answers, which means I have to split my page in half and consider a second possibility. Yeah? So, I won't continue with that because it is just like the first one. So what I'll do for you is just set the problem up. So if you can write that one down, and then it would just be here, continue with IESF. Andy?
Is there any difference between minus 3x and 3x?
No, there'll still be 6 answers. But there's the possibility that you might have to fix all your angles at the end, which is okay. Yeah.
What is the?
I know the one. I know what you're going to ask me, and I'm going to say that now in a minute. Okay? Yeah. You're going to ask me, what if there's a sine squared and a cos? Yes. I can read minds when it comes to maths. I know what's going to come up next. So the next thing is, if you were to look at, for example, 2c, you would get 49 sine squared 3x plus 75 degrees. Sorry, I'm getting muddled up. It's 49 sine squared 3x plus pi over 36 plus 70 cos 3x plus pi over 36 minus 74. Now, as you notice, there's a big problem here. And what's that big problem?
Sine
this is sine squared and this is cos. They are not the same thing, of course, meaning it's not really a quadratic, which is a problem. I can write this as 49 sine squared. I'm just going to write s for short, okay? Sine squared plus 70 cos minus 74 equals 0. Now, how do I fix this? Well, what you do is, you must remember there's a rule from trigonometry. I don't remember if I gave it to you. We can talk more about it in the next class, but there's a rule that says sine squared plus cos squared must equal 1. Always, regardless. In fact, the proof of this comes from Pythagoras' theorem. Anyways, with this rule, you can now convert between sine squared and cos squared. So I can convert the sine squared into 1 minus cos squared. Yeah. So I get 49 times 1 minus cos squared plus 70 cos minus 74 equals 0. So I get 49 minus 49 cos squared plus 70 cos minus 74 equals 0. So that's minus 49 cos squared plus 70 cos. 49 minus 74, minus 25. What is it? Minus 25? Now look at what I've done. I've turned this back into a quadratic of cosine. Minus 49 cos, what was it? 3x plus pi over 36 squared plus 70 cos 3x plus pi over 36 plus 70 equals 0. Now, please give me the two roots here, if there are two. Maybe there's one, maybe there's none, I don't know. So A is minus 49, B is 70, and C also 70. 2.1 minus 0.6, show me, 678, so 68. Now look, cos that angle, I won't bother rewriting it, okay, it's the same thing, dot, 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 equals that. And then you have to look at this one, cos that angle, dot, 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 equals that. So here you would use IESF, and here you would use IESF. This will turn out to be fine. But the moment you type in cos inverse 2.1, you'll get an error on your calculator. This is because cosine can never become more than 1 or less than minus 1. Yeah. So although we get two answers here, this one I have to reject because it does not provide us with a path we can follow. So we're now reduced the problem back to what I gave you in the first example, which is just this type of equation. So my point is, question 2 is quadratic, but you can return it back to linear. And even question 2c, which is a quadratic of sine and cosine, can also be returned back to linear. So really the key thing here is how to solve linear trigonometry equations. Okay, I'll give you a couple of minutes to practice some. So